that you're financing with interest, there's some formula that is used. Usually it's already in the computer for the person that's doing it, but they use a specific formula based on how much you borrow, what the interest rate is, and how long it's taking you to pay it. So that's where some of this stuff is used outside of our classroom. So this is a formula that you should know. I'm going to write it up here because it's kind of small. That just says to the power. A equals P times 1 plus R to the N. Anytime you have an exponent that could be a letter, that's why we're doing that with logarithms here. Really important things here in this green box. It tells you what everything represents. A is the amount of money you have after so much time. P is the principal balance, which is the same as the starting balance. This kind of looks like the population growth model that we had. 1 plus R, instead of talking about the growth rate or the decay rate, we're talking about the interest rate on your money. And N is the number of years that it takes. And so you've done these before. These shouldn't be brand new here. If I asked you to find the amount accumulated after investing a principal of $1,500 for 6 years at 7% interest, you're just plugging it in. Like, you're not even going to do a logarithm on some of these problems. You're just practicing with the formula. So hopefully not very complicated to do here, but again, calculator use is really important. Many people miss these problems because they don't use calculator correctly. I'm trying to find A, and I'm just going to plug all this stuff in. The principal is $1,500 times 1 plus, remember, just like the population growth, we're not going to say 1 plus 7, 7% as a decimal would be 0.07. And what am I going to put up here next one? It's compounded annually, which means once a year for 6 years. And my calculators, you can just type all this in at once. Really important that if you're going to put 1 plus 0.07, you better put that in parentheses if you want the whole thing taken to the 6th power. Probably you could just put 1.07 because you could have that in your head. And if this is all about interest, your answer should be bigger than what you started with, right? So I'm just going to jump ahead here, and I got an answer of $2,251.10. Did you get that? Decimals. If they're talking about money, do not give me 4 decimal places, right? If we're talking about money, it's always going to be rounded to 2 decimal places. So that's kind of the basic formula. But what about if the interest is compounded more than once a year? The formula changes a little bit. That's what's on the next page here. And again, all of these words tell you what all these letters represent. And that's what you have to make sure you know is what all those letters represent. And again, this is really small. That should say KT power. Write that in there until it's squished. The only difference between this formula and the one before is if it's compounded more than once a year. Like, I know my savings account is compounded quarterly, which means 4 times a year. I look at my balance, they give me like 7 cents interest. So that's the extra part. K is the number of times it compounds per year. And so you have to think about, if it's yearly, K is 1. If it's quarterly, K is 4. If it's daily, K is... If it's monthly, K is 365. 12, right? So you have to make sure that you read the problem to know what to plug in for K. But other than that, it's the same thing. So if we have a principal balance of $1,500, 5 years, interest rate of 7%, just like last time, the only difference is it's compounded 4 times a year. Again, it's pretty much a big calculator problem. Because it says annually, which means you could use this formula, but K would just be 1. So if you take R divided by 1, 6 times 1, it doesn't change. This is the one that I use all the time, and write that as a decimal. Divide by 4 to the kt power, so 5 years times 4 times a year, so that would be to the 5 times 4 power. This is where I think doing a little simplifying isn't always the worst idea, because if you type it in just like this, there's a whole lot of parentheses. Like if you don't type in 20 as your power, you have to type in caret, parenthesis, 5 times 4. Because your calculator does it in the order that you plug it in. Like it follows the order of operations. So for me, I went ahead and I said, what is 1 plus 0.07 divided by 4? And that was 1.0175. And then 5 times 4 is 20. The less parentheses you need on your calculator, usually the better chance you have of not making a mistake. And so if you don't have a calculator with you, you should come up here and get one, because these aren't hard problems, but you got to make sure you're getting the correct answer. A 20th power, and after 5 years at 7% interest, you should have about $2,122.17. Did you get that? This is why I say do this, Henry. Don't do this. It's way too many steps. Exactly it is. You just put caret 20. 1,500 times 1.0175 caret 20. Like no parentheses needed if you simplify it. Get clear. 1,500 times 1.0175 caret 20. Enter. Compound interest, this is really the same thing that we just did. Like, this is the same thing we just wrote out, so there's no need to write that again. But this is the one that you really should know, right? A equals PE to the RT. If your interest is compounded continuously, which I don't know of anything that you can invest your money in and you get compound interest continuously, but many things that you finance probably do that, because that means it's compounding all the time. The more times it compounds, like the more money that you can get, because it's compounding over and over again. And so if it says compounded continuously, you have to know which equation to use. And so that's the big thing I want you to know on these problems. We're not even doing logs right now. We're just using the formulas. I'll give you the formulas, but you got to know which one to use in which case. And most people like this one because there's not that much work to do. Principles, what you start with, R is interest rate, T is the time in years, and you just get to plug that in your calculator. So this would be 1250 times E to the 0.054, right? Make sure you write that as a decimal, times 6 years. And again, check to make sure you're getting the right answer. On my calculators, when you type E, it automatically puts the caret in the parenthesis. So type all of this before you close that parenthesis. So you would type 1250 times E, and it automatically does this, 0.054 times 6. And since it's at the end, you don't even need to close that parenthesis. What do you get? $1,728.31. Yes? Again, money. I expect you guys. Every cent matters. Okay, so those I kind of went through really quickly because really they're all things that we did last year in Algebra 2 when we did this section. And there's not really the log stuff in it. Now, they're asking you to solve for something that's in the exponent. That's when the whole log LN stuff comes into play. So then that's the second part of your homework. And these take a little bit longer. And again, I printed them out for you so we don't have to spend time writing it down. Again, first thing you got to figure out is make sure you know which formula you're using. Plug in everything you know, and figure out which variable that you're trying to solve for. So we're investing $8,000 interest rate compounded monthly, right there tells me which equation to use. Which one am I using? Yeah, you have to use the one with the K, ROK. And I'm trying to find how long it's going to take. So what variable should I be solving for? Time. That means you should be able to plug in everything except for t into that problem. And then use what we know about equations and about logarithms to solve this problem. Probably yes. I feel like the two basic ones aren't that bad, but I'm probably gonna because I'm gonna press too far. Not yet. We'll see. Let's plug in what we know. What am I gonna plug in for A? 16,000, right? A is what you have at the end. We want to know how long till her payment has grown to 16,000. The principal is what she starts with, which is 8,000. The interest rate is 0.09. Compounded monthly, what is K going to be? To the 12t power. Right? That's the step that you have to make sure that you can plug in. And then we're just going to solve this. What should I do first in this problem? Yeah, and kind of both of those, I'm going to do both of those steps at once. I'm going to divide this 8,000 over. There's no need to distribute it in. And I'm also going to add that together to make it one thing. If I divide by 8,000, that's really nice, because 16,000 divided by 8,000 is just 2. And just on my calculator, I'm going to take 1 plus 0.09 divided by 12, and I got 1.0075. Did you get that? To the 12. And once you do that first step, this really isn't so bad. You just have to know what do you need to do if you want to get that t out of the exponent. L in both sides. Anytime you see a letter in the exponent and you want to take it out, you can common log both sides or L in both sides. Why do we choose those two? Because that's what we can do on our calculator. I always do L in. I don't know why, but I do. And why does it work out so nice to L in both sides? What am I able to do now? But what do I need to do? Wait, why did I take the L in? Because the property says I can take this and move it to the front. You're right, Henry. I am going to divide that. But the only way I can is by moving this to the front. And actually, if we wanted to, could we just do it all in one step? Could I divide by 12 and ln of 1.0075? You okay with that? Or you can do two different steps. Like that's going to get t by itself. Again, calculator issues. If you're doing this all at once, I would just put parentheses on that just to make sure. Or you can do it in two separate steps. Take ln divided by the ln 1.0075 and then take that answer and divide by 12. Anybody want to give me their answer? 7.73 years. If it's compounded monthly, let's think about this. Let's be a little more exact. 0.73 is pretty close to what fraction? 3 3/4, 0.75. So do you agree that that's almost 7 3/4 of a year? How many months is 3/4 of a year? So I believe in the book for this problem, they say that because it's compounded monthly, at what month is it going to happen? 7 years, 9 months. not getting that answer? And this is where on a test you have to, one, make sure your answer seems reasonable. Like if you got like 8,000 years as your answer, that's probably not right. And if you get like a really small decimal or a negative number, like that should tell you either you've entered it wrong or something's wrong in your equation, because you should be able to say that your answer makes sense. Did you get it? Are you typing it all at once or separate steps? Like, if you type ln of 2, did you close the parenthesis after the 2? Like, ln of 2 divided by parenthesis 12 times ln 1.0075. You gonna get that? Maybe I should do it all in a second. I'm sorry. I just typed in what I have up here and I got 3. Like it really is the same thing. If it helps, do it separately. Like do ln of 2 divided by ln of 1.0075. It equals, and then divide by 12, and you should also get the same answer. But it really, like, both ways should work. That's why it's really important that you practice these as we do in class, so that you can figure out what is wrong. Did you get it yet? 12. 7.73. Yeah, I can do it. I mean, that's beautiful. When you're looking at this, first thing I always do is figure out which equation to use. Which one's that going to be? The same one we just did, because it's compounded monthly. And then, so I'm going to start with that. A equals P times 1 plus R over K to the K T power. And then the second thing I always do, before I start plugging stuff in, make sure you know which variable that you should be solving for. And what should I be solving for in this problem? The interest rate, which means that's going to stay in R, and every other letter should have some number in it or some way to get that number. So do we agree that P is 8,500? Yes? I don't know what the interest rate is. What is K in this problem? Monthly. And what is T in this problem? What is A in this problem? 3 times 8,500. And sometimes, because we're talking about tripling here, sometimes they don't even tell you what you're starting with. They just say, here's the interest rate, here's K, how long will it take for this to double or to triple? You don't even have to have the starting point, because you agree that if you wanted this to triple, we could just say 3P equals P, and the piece of P's out. See what I'm saying? If you want it to double, you don't have to have the starting amount, because every time you can divide both sides by it, and then you don't have those many numbers to do it. So just keep a lookout for those. So I'm not even going to keep that 8,500 in my problem. I'm going to divide both sides by it. Which actually helps me a lot, because now I have 3 equals 1 plus R over 12 to the 60th power. What am I going to do to solve this? Can I just take 1 to the 60th power and then this to the 60th power? What would I have to do if I was going to like multiply this all out? FOIL it 60 times, right? Like it would be 1 plus R over 12 written 60 times. That would be a bit crazy. ln both sides and move to the front. I think that would work. This whole thing would be the ln. That would be one thing you do. Something else you could do is, if this was all squared, what could we do to get rid of the square root? Oh, I just said it. You could take the square root to get rid of square root. What could you take to get rid of the 60th power? You could take the 60th root. Seems kind of weird, but both the ways will work, so it's whatever you want to do here. Maybe you want to ln, ln of 3 equals, I'm going to go pull that down and say 16 ln of 1 plus r over 12. Oh, wait a minute. I foresee a problem with lning both sides. Because I can divide 60 over, but is there any way, like, what would I do with this now? E both sides? You can't break it up. Like, I think we'd have to then E both sides again. We would eventually get the right answer, but I think I'm going to go with my 60th root if you're okay with that. I think that would work, Stephen. It's just going to get ugly as well. I thought it might be easier than the 60th root. So if I'm going to take the 60th root, two ways you can do that. You can write it like this, like a big root sign, and put a 60 right here. Or we could also write it as what fractional power? 1/60th. So I'm going to write this as 3 to the 1/60th power. And this 60th root to the 60th power, I get 1 plus r over 12. Agree with me on that? There is a root button on your calculator that you can take the 60th root. I just tend to use the caret button more, like do caret 1 over 60. And then can I get r by itself? And again, I'm not going to do this decimal till the end. I'm going to do it all at once. So I'm going to subtract 1 and get 3 to the 1 over 60th minus 1. And then I'm going to multiply by 12. And if they ask me for the exact answer, meaning don't round, which we're going to, you could say the answer is 12 times 3 to the 1/60th power minus 1. When you type this in your calculator, if you're doing the 1/60th power, make sure you put a parenthesis around that. Like, I'm going to type in 12 times parenthesis 3 caret 1 divided by 60 minus 1. Let's see what this looks like. Should get that. Again, you can do this in multiple steps if you want, but if you're going to do it all at once, you're going to type 12 times parenthesis, because we're multiplying by everything here, 3 caret parenthesis 1 divided by 60, close the parenthesis, minus 1, and then if you want to close the other parenthesis. If you are not good with these grouping symbols, you have to just do it a step at a time. Like, take 3 to the 1/60th, hit enter. Minus 1, hit enter. Multiply by 12, hit enter. Because during a test, you come up and you say, I got a negative number, I know it's going to be negative. You got to know how to use calculator to get that answer. Did you get 22,217? And if we're talking about the interest rate, what would interest rate be? Not even going to be specific and say 22.17%. That's pretty high interest rate. But you have to remember, you do the 60 number, and then the button, and then the yes. Oh, okay, I see what you're saying. I thought you were about the reset, but yes. Questions about that? All right, last one. This is what I was talking about, that they don't have to give you the actual value if you're wanting to find just how long would it take for any investment to double if the interest is earned at 5.75% compounded quarterly. Which equation am I going to use? Same one, right? Like that one we were using a lot. And we're looking for T because it says how much time. And a lot of people get to a problem like this and they say, well, there's not enough information because they don't tell me what I'm starting with or what I'm ending with. that if you're just talking about doubling or tripling or anything like that, I just want to show you that you don't actually need what you start with, because if P is the original amount, how much would be there after it doubles? 2P, right? If we wanted to know, like, how much until, if we were going the other way, we were paying something off, if we wanted half to be left, we would put half P there, right? Half-life, we do that a lot. Watch your decimals here, that's where a lot of people make a mistake. And quarterly is how many times a year? And we're trying to solve for T again. So anytime you're solving for T, I think it's easier. That one that we solved for R, I think was the hardest one because we haven't done stuff like that. 60 is we've done that before. But this is really nice. The P's cross out. Do that on your calculator. And I always write all those decimals down. I got 1.01437.5 to the 4t power. And anytime the variable is an exponent, log base 10 or ln is what you're going to do on these. So there are a few variations, but basically we're going to do that. Sometimes I get lazy and kind of don't show all my steps here, but I'm going to go ahead and bring that out. And this is just like the last one we did with the 12. You don't have to do it all at once, which means we could divide by the ln. Do that, get your answer, and then just hit divide by 4 again, right? Like you don't have to do it all at once. Do ln of 2 divided by ln of 1.01437.5, and then take that answer and divide by 4. I just think it's easier if you just write 4 up there, but you do have to let your parentheses when you do that. Yes. It's in years. Time is always in years. I got 12.14-ish years. Yes? Since it's compounding monthly, again, in the back of the book, they're not going to say, oh, sorry, it's compounding quarterly. They're not going to say 12.14. They're going to round that to the next interest period. So if it compounds quarterly, what would be the next interest? How many months would it be before you got? Because you, like, if you're going quarterly, you round up to the next quarter. Like, that's closer to 12.25, so we would say 12 years, 3 months. Quarterly is going to go every 3 months. 3 months, 6 months, 9 months, 12 months. So just when you look at the back of the book, I just want to show you that they're going to give you answers like that. Like, you have to, well, you know, it should be.